Okay. Ba-da-da-da-da-da. Okay, so 2 people said it. Right, work done. Equation you'll need then. Energy transferred is equal to the force multiplied by the distance. Sorry for this E, and that equals 2. So the work done is measured in joules. It's a unit of energy. 1 joule is released when you move an object with 1 newton of force over 1 meter. Okay? So the measurement of 1 joule is 1 newton of force multiplied by 1 meter of distance. The work done equation is paired with 2 other equations. Energy over time to give you power, and also efficiency. Efficiency is useful over total. The Queen's pet cat called Piv. So energy can be referring to the electrical energy in a circuit. It can also be referring to the work done. So we could write down this as well as power is force multiplied by distance divided by the time taken. This is still going to have a unit of a watt. Even if it's electricity, it'll still be measured in watts. Electricity and physical work done will always be measured in watts. Efficiency, remember, useful divided by total. To find useful, you get the total energy, take away the waste, and that gives you your useful energy. This can come up in different contexts as well. So one past paper question had an athlete running on a treadmill for a certain amount of time using a certain amount of energy. You have to work out the power. Was he more powerful in session 1 or more powerful in session 2? Power just refers to the energy transferred divided by the time taken. If I have got an object moving in a particular direction, and if that particular object has got a certain amount of kinetic energy, and if this particular object is on wheels and has brakes, and those brakes stop the object, the 100 joules of kinetic energy will be transferred to 100 joules of work. 100 joules of work. So the kinetic energy will be transferred to work. This will be the force of friction on the brakes for a particular distance in space that's going to reduce the kinetic energy of whatever object is moving. So you could as well, you could join up the 2 equations for an object that was moving with particular kinetic energy and then finished. What's the force, or what's the distance with this amount of force? You can join up those 2 equations. While we're on it, actually, it's not about work done, but kinetic energy equals gravitational potential energy. If I have an object that's a certain height, and this object that's a certain height falls, and just before it hits the ground, it will have transferred all the energy that was up at that particular height. How do we calculate the gravitational potential energy? GPE, it can also be written down as EP, is equal to the mass times the gravity times the change in height. The number that we always use for gravity is, shout it out.
10.
Thank you. Unless they specify 9.81. If they say 9.81, use 9.81, you're not going to get your marks. This object will start to fall. As it falls, the gravitational potential energy store will fall and the kinetic store will increase until the gravitational potential energy store is empty and the kinetic energy store is full. When the kinetic energy store is full, all of this GPE will have been transferred to KE, to kinetic energy. The equation for that is 1/2 times the mass times the velocity squared. Which means you can have a question where you're not given the mass of an object, but it asks you to find the velocity of the object just before it falls, okay? And I'll show you something like that. Just let me think it through first, okay? This is a ball. The ball was 12 meters in the air. It was 12 meters in the air, and it has got 250 joules of gravitational potential energy. What was the mass of the ball? No, bad example. But we'll try it anyway. Yeah, we'll try it, shall we? No, I don't think it's going to work. Well, I'll try it anyway. I can edit these videos now, so if I make a mistake, it's not going to matter. I don't have enough there to find the mass by itself. Oh, actually, I do. Yeah, I do. Just going to use GPE, aren't I? You know, it's hard to come up with these things off the top of your head. But it's okay, I've got the actual question that I would use it for. How would I find the mass of the ball? I would have my 250 joules of GPE. I would keep M, I would have 10, and I would have 12. I would rearrange that to 250 over 120, and that would give me my mass, whatever that is. It would be 2 point something, 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 something. How could I find the velocity of the ball? That's a much better question. What's the velocity of the ball just before it hits the ground? What's the velocity of the ball just before it hits the ground? Because I don't have the mass, so I can't use, by itself, I can't use the kinetic energy equation. It hasn't given me mass, so I can't by itself use this equation. I've got this, I don't have that. That's a number that's constant, and the v squared thing, I'm trying to find that. What we do in this case, which I should have said the first time without looking silly, is combine our two equations together. Okay, I've combined my two equations together. Because I've got mass on both sides, what can I do with them? Cancel them out. Okay? Now mass doesn't matter. I'm trying to find the velocity of my ball just before it hits the ground. Now I can start collecting my terms. What number do we have for gravity? 10 newtons per kilogram. What about my height? 12. Can we start using units when we shout them out, okay?
Meters.
Thank you. For my velocity, I don't know. So, I will have gravity times change in height is equal to 1/2 times v squared. Gravity, delta h, times 2, we'll cancel that, is equal to v squared. Square root of 2g delta h equals v. Then I just have to substitute square root of 240 off the top of your head, anybody? Yes, you're right, it's I don't know, but it doesn't matter because it's the same process that you're going to use every time, okay? They love giving you this kind of a setup. So, just to recap, if I've got an object that falls, the gravitational potential energy up here will transfer into a kinetic energy store down here. If they ask you to find the velocity just before it hits the ground and you have the mass, then that's fine. You can use kinetic energy equals 1/2 mv squared. If they ask you to find the gravitational potential energy, you can use this all by itself. GPE equals mg delta h, remembering that delta stands for the change in height. I'll come back to that in a second. You can combine these two equations. GPE equals KE. We assume 100% efficiency, when in actual fact it won't be, because as the ball falls, some energy is going to be dissipated as heat. So when the ball hits particles, some energy is going to be transferred to the particles of the air as it falls. We can write this down, mg delta h equals mv squared times 1/2, cancel out the m's, g delta h equals 1/2 v squared, that goes down to square root 2g delta h equals v. If you're not comfortable with working all that out, then at least know the equation. Yes, sir?
Why times it by 2?
Getting rid of the half. I could divide it by 1/2 or I could times it by 2. 4 divided by 1/2 is 8, 2 multiplied by 4 is 8. So they're the same thing. Good question, thank you. What did I think of? Oh right, something I've not seen before which might happen. I've got a ball that's 10 meters in the air and it falls onto a table that's 1 meter in the air. It's got a mass of 1 kilogram. Can you tell me the gravitational potential energy of this ball? Collect our terms. Gravity we'll say is 10. Mass we'll say is 1. Change in height?
Meters.
Yes. Okay, delta H, change in height, because it's only gone down 9 meters. Don't use that as a first term. GPE equals 10 times 1 times 9, which is 8,000. Lol. Another thing I just thought about it as I was doing that, efficiency can either be useful work divided by total work, or, sorry, let's just do a quick fit, you know, for the fans, the subscribers, yeah?
No, it's fine. Sorry if I'm...
No, it's okay.
Is there any chance we can just get together for 5 minutes? I know you
Yes.
do intervention, like downstairs in Mr. Hollis was
I'll finish this and I'll be down there in 2 minutes.
Awesome, thank
Alright,
you.
thanks, Miss. This is going to have to be...
Edit.
No, it's going to be featuring Miss Walker.
Oh.
Yeah, FT. like a superstar. Okay, useful work divided by total work, or useful power divided by total power. Okay, so you can get efficiency of power as easily as you can get efficiency of work. Okay, that's 10 minutes. Any questions or anything you want me to go over? Sweet, goodbye.